Vamshi sir, have you joined?
Yeah, good evening.
Good evening, sir. So, participants will be starting off with the second session of the day.
Can I just see the presentation? I will share it.
Yeah, please. Please share the screen, sir. Meanwhile, I'll introduce you to the participants. The resource person for the second session is Dr. Vamshi Krishna. And it is my honor to introduce our esteemed speaker for this session, Dr. Vamshi Krishna, currently serving as a Senior Technical Officer at the CSIR National Geophysical Research Institute, NGRI. With 16 years of rich and research and development experience, Dr. Vamshi is a highly accomplished expert in cutting-edge technologies. He holds a BTech in Electronics and Instrumentation from JNTU Hyderabad and an MTech in VLSI and Embedded Systems from Cochin University, Kerala. His research interest spans a wide range of advanced topics, including drone and UAV technologies, embedded systems and cyber physical systems, emerging VLSI trends, sensor electronics, magnetic and electromagnetic methodologies. Dr. Vamshi's profound knowledge and hands-on expertise make him a leading figure in his field. We are privileged to have him here today to share his insights. Now I would like to invite Dr. Vamshi Krishna, sir, to kindly take over the session.
Thank you, madam.
Thank you, sir. You can please start the sessions.
Okay. Good evening, all of you. So before I am going to the topic, I would like to express my best wishes and congratulations to the entire coordinating team, particularly Maulana Azad National Urdu University Director and team, and the coordinator Dr. Muhammad Yusuf Khanji and Ms. Fatima Madam Ji. And also I thank AACT ATAL Training Program Committee for giving this kind of opportunity for making this program to be happen to conduct this kind of programs.
Thank you, sir.
So today coming to the topic. One second. Hello. Yeah. Yeah. Okay. Presentation we are unable to see?
Yes, sir. We are not able to see the presentation.
Okay. One second. Stop sharing. 1 second. I will just see. So I should select full screen, share full screen. Huh? Yeah, entire screen. Full screen. But okay. Can you see my presentation now? Okay. So from where I see there is a present now button is there. So Oh, yeah, okay, entire screen. Yeah, now I am able to. Yeah. I think now you are able to see.
Yes, sir.
Yeah. Thank you. So once again, good evening to all of you. So the today's topic is energy storage systems and innovations. So basically, one related to energy. As I'm working in engineering from past 15 years, we are working on a research and development area, especially in energy sector. You can say mineral exploration is one of the area NGRI is doing R&D for exploring the exploration of minerals under our mother earth. So where some of the very crucial and important minerals like uranium exploration, these are the one of the area where we explore for the net across the nation to utilize the mankind. So in that point of view, coming to the today's topic, energy storage systems and innovations. So I will briefly go to the fundamentals like what is energy and why you need to store and what are the kinds of energy storage systems, how this will be utilized in our societal developments, and what are the case studies and applications, and what is the future of the energy storage systems. These are the things we will discuss in coming session. So now coming to the what is energy. So you can see energy is defined as the ability to do some work. So with energy only, we will be able to do any kind of work, and energy can be found in many things and can take different forms. For example, kinetic energy, potential energy, chemical energy. These are the kinds of energies. And also energy is never lost, but it can be converted from one form to another form. This is the one of the typical feature of the energy. Now, another question is that why you need to energy storage is required. So because see, the energy is needed to secure for the human mankind and reliable. For example, you take as reliable electricity supply. We need electricity supply 24 hours a day. And also need to make a more use of renewable energy resources such as solar and wind, because we are lacking of electricity storage in our country, and not only throughout the world also. To reduce our reliance on non-renewable energy sources like fossil fuels such as oil and gas. So we depend on the multiple alternative resources where we need to store the energy and utilize for the societal applications. So coming to conversion of excess electricity into different forms of energy, it can be reconverted into electricity with a minimum losses. This can be done to reduce the gap in supply and demand of electricity. So always the production as well as consumption will have a lot of band gap where most of the time we won't be able to meet the demand, but supply is lacking, particularly for the energy sector. So it can be applied to both conventional sources of electricity and renewable energy also. So coming to electricity storage systems, low power applications in isolated areas, essentially to feed transmission and emergency terminals, medium power applications in isolated areas, and network connection applications with peak leveling, and power quality control applications. These are the areas where we can use electricity storage systems. And coming to the world net electricity consumption, when the survey happened at 2002, they have estimated kind of kilowatts hours is required energy. Coming to 2025, roughly 26K of billion kilowatt hours are needed. This is the kind of consumption has happened for the whole net electricity consumption. So coming to renewable energy potential in India, you can see from the picture the total reserve of energy, renewable energy potential in India, roughly around 8,96,603 megawatt. Out of this, most of the energy comes from the solar power, and next will be the wind power, and in very few will be hydropower and biomass power. So coming to our India, nationally, what is the energy balance? So this is, even though it is a bit earlier source of information, but even now also there is a lot of, as I told you, there is a huge gap between the consumption and production of the energy, and as well as storage of the energy. So coming to what is the importance of these energy storage systems? So first, for renewable energy sources and variable outputs, energy buffering, and importance in present context, and why we need this kind of technologies and devices, particularly to store this energy. So then coming to what are the different types of energy storage systems? It can be classified as mechanical energy storage system, magnetic, thermal, and chemical energy storage systems. So why we need to store, and what is the value of storage, and where we utilize this kind of storage? So these are the four applications where we use this kind of storage energy, particularly residential consumers like our home electricity supply, and commercial consumers like industries and grid operators and utilities. These are the applications where we utilize this kind of storage energies. So from this picture, you can see both the sides. It is clearly visible that there is a renewable energy and non-renewable energy. So the renewable energy is generated from wind, geothermal, water, solar, and biomass, etc. So at the same time, the non-renewable energy is generated from oil, coal, and nuclear and natural gases. So we'll see what is the difference between renewable and non-renewable energies. So renewable energy, these sources of energies can be used again and again, and these types of sources are inexhaustible. And particularly the advantage with the renewable source of energy is that it does not pollute atmosphere. It protects the environment. So what are the examples of renewable energy sources? Solar energy and wind energy. Coming to non-renewable source of energy, it cannot be used again and again, but the sources are exhaustible and cannot be renewed. The problem with this non-renewable source of energy is that it causes atmospheric pollution. Our environment will be spoiled because of these non-renewable energy sources. Example like coal, petroleum, and including even, you can say example as the petroleum pollution from the automobiles also is creating the environmental pollution. So use of renewable electricity generation and improved energy storage technologies have several benefits. So using renewable electricity generation, these are the benefits as a security, a more efficient grid that is more resistant to disruptions, and environment. It decreases the carbon dioxide emission from a greater use of clean electricity, and economy wise, increase in the economic value of wind and solar power, and strengthened competitiveness in the clean energy race. And also it creates a lot of job opportunities, particularly a new income sources from rural landowners and tax revenues for particularly for wind and solar development, because the wind and solar developments will happen at a rural areas where we have a lot of lands are supported, and a lot of rural landowners will be supported to develop this kind of energy sources. So coming to what are the types of energy storage? So it can be variety of types of energy storages, like biological, you can call starch, glycogen. When it comes to chemical, hydrogen and biofuel, and liquid nitrogen. And comes to electrical category, there are capacitors, supercapacitors, superconducting magnetic energy storage. And under mechanical category, we can say compressed air energy storage, flywheel energy storage, spring gravitational potential energy storage device, hydroelectric energy storage. And electrochemical, you can call batteries, flow battery, fuel cell, ultra battery. Out of these types of energy storage systems, few of them we will see in detail what are the advantages, how it operates. These things we will see in coming slides. So also thermal, under thermal, these are the types of energy storage systems like ice storage, molten salt, steam accumulator, solar pond, hot bricks, serogenic liquid air and nitrogen, seasonal thermal store. These are the types of thermal energies. So what are the variations in energy demand? So it's already discussed that the demand for electricity in the utility system is varies in hourly basis, daily basis, and season to season. So say for example of electricity. So electricity demand will always vary depending on the hourly basis and daily basis, and also season wise, because see in summer we use a lot of electricity, but whereas winter we use less kind of demand for electricity. And what are the solutions for this? Because we can increase the efficiency of this and reach the demand and supply gap. So the interconnected network is one of the solutions, and use newer plants used for base load and older plants for additional loads, and construct not expensive, low infrastructure small plants, and also use energy storage systems. These are the solutions where we can reach the demand by supplying the energy to the common needs. So as I discussed different types of energy storage categories, under that the technology types, if I divide into broadly into 4 types, particularly as a 4 features, the technology, what kind of technology, like batteries, flywheels, electrochemical capacitors, and hydro and compressed air energy storage, and how the theory of operation happens, and state of the art technology, and what is the cost projections. These things we will see in detail. So coming to the first technology, batteries. So everyone is very familiar with the batteries, as everyone is using the batteries and technologies, even from your smartphone to the automobile and other applications based on batteries. Many societal applications are running. So the battery storage energy chemically and uses electrochemical reactions to produce electricity at a fixed voltage. So what are the pros and cons of these batteries? So basically it's a convenient voltage characteristics and convenient sizing. So because of sizing only we are able to use in smartphones and other computers and other many gadgets where what we daily in our daily life we use. And what are the cons? I mean, the disadvantage of this one. So the battery life cycle is very limited, and voltage and current limitations, and requiring complex series and parallel systems, often present environmental hazard. Sometimes it blasts. So these are the issues, major issues we face with the batteries. So particularly to increase the efficiency of the battery, we use series and parallel integration with the batteries and try to improve the power of the system. So battery application suitability, batteries are suitable for applications that require supply of relatively large amount of energy storage, that is greater than 1 megawatt hour over long periods of time, 15 minutes or more, where rapid recharge is not necessary and where maintenance can be reasonably performed. They are not especially suitable for environmental sensitive sites, remote locations, or applications that require rapid discharge and absorption of energy. These are the limitations. So from the picture we can see, I think many of the people aware of the battery, because battery is a very routinely used technology at present lifestyle. So at the bottom you can see there is a series of batteries connected to increase the power of the required amplitude. So when it comes to the different kinds of battery technologies, starting from lithium ion, lead acid, so many different kinds of battery technologies, the life cycle is very limited. So out of that, the lithium ion gives the best voltage current characteristics, where it can support the requirements as per the power needs. So coming to one of the category, lead acid batteries. The lead acid battery is the oldest known type of rechargeable battery and was invented in 1859. This battery usually have several in series connected cells, and each delivering 2 volts and each consisting several spongy pure lead cathodes, positive load oxide anodes, and 20 to 40% of solution of sulfuric acid that acts as an electrolyte. So what are the advantages and disadvantages? And advantages comes to easy and therefore cheap to produce, easily recyclable, very high surge to weight ratio, capable of delivering a high jolt of electricity at once, which is why they are so suitable as a car starters. It's a mature technology, more than 150 years of experience and development has happened already. And when it comes to the disadvantages, it's very heavy and bulky and rather short-lived. There are environmental concerns. Although safe, lead is very toxic and exposure can cause several severe damage to the people and animals, and corrosion caused by the technical reactions. These are the disadvantages of lead acid batteries. And coming to lithium ion batteries, so lithium is the lightest metal, and at present the lithium ion batteries are nowadays very frequently used batteries because of the maximum power efficiency with these batteries, and it's a material with lightest metal with the highest potential due to its very reactive behavior, which in theory makes it very fitting as a compound for batteries. Just as the lead acid and most other batteries, a lithium ion battery by definition use chemical reactions to release electricity. So what are the advantages of lithium ion batteries? So advantages are, as I told, frequently used at present lithium ion batteries. So highest energy density in commercially available batteries with huge potential, and provides higher voltage per cell, as lead as 2 volt but this is 3.7 volts compared to 2 volt lead acid battery, and low energy loss only about 5% per month, and lithium and graphite as source are available in large amounts. So these are the materials we use. And coming to disadvantages, it's very expensive. That is the reason nowadays all electrical vehicles they use lithium-ion batteries. I think 40 to 50% of the price of the goes to the lithium-ion batteries where they use in electrical vehicles. So that's why it's very expensive, and complete discharge. If the battery completely discharges and destroys the cells, so we should not discharge completely these lithium-ion batteries. You need to recharge when it comes to the at least 20% of the battery level, and it deteriorates even if unused. If you are not using, also the life cycle will come down. And the most important thing is that the lithium is a flammable in contact with atmospheric moisture. So this is one of the concern with the lithium-ion battery. So what are the other batteries in development? So redox flow battery. This is a battery which is in the development. These batteries technically are similar to conventional batteries, except that the electrolytes, there are different forms using one or two different fluids, and it can be exchanged, meaning that if the battery is discharged, the fluids are replaced with loaded ones. So the fluids will be replaced. This concept could, in theory, become very handy for electric cars, as you could charge your car simply by refueling, just as you do now. So if this kind of batteries comes up, so we can change the fuel in the battery and it can be reusable. So another kind of battery is sodium battery. The liquid sodium sulfur battery is yet another type of battery in development, but already operational in some countries like Japan. About 250 megawatt of sodium battery power have been installed there, and 5 sodium batteries have the advantage of relatively high density with up to 240 watt hour per kg, as long as lifespan of 10 to 15 years and high efficiency of 75 to 90%. But they need to be operated at high temperatures, that is 350 degrees, to get the sodium liquid. So these are one of the concern, but it has the very potential applications, and it can generate the huge megawatt of power. So another kind of batteries in development is zinc air battery. Just like the lithium air battery, the zinc air battery uses air as a second component. Zinc air has been a focus in development for a while because of its safety aspects and potential in density, but was dropped due to the low efficiency and short life cycles. 2 independent companies claim to have solved these problems. So we have to see how the zinc air batteries will evolve, because it is particularly for the safety point of view, which is very useful to the societal applications. So another technology is conversion of electrical power to the gas fuel. So when using surplus power from wind generation, a concept is sometimes called wind gas. There are currently 3 methods in use. All use electricity to split water into hydrogen and oxygen by means of electrolysis. So by converting electric power to gas fuel, this is one of the technology we use to convert power to gas. So this is the energy losses during this process. So another energy storage system is called thermal storage. As you see, the technology that stocks thermal energy by heating or cooling a storage medium so that the stored energy can be used at a later time for heating and cooling applications and power generation. So by storing thermal energy by heating, we can generate this kind of thermal energy and later it can be utilized for the power applications. So what are the advantages of thermal storage energy? The thermal storage energy storage offers the option to improve output control for some energy technologies, able to reduce mismatch between supply and demand requirements, and low maintenance requirements. So it has low maintenance and reliable and well understood technology. And coming to disadvantages, the energy stored decreases with the time due to the heat losses. And also some storage technologies are still in developing stages. And also it is expensive. For seasonal storage, exam are needed big surfaces. So when you compare with the efficiency of different technologies, so the maximum and minimum efficiency, we are able to see lithium ion gives the maximum efficiency 95%, also flywheels and SMEC. So at present, lithium ion batteries are efficiently performing the requirements. So when it comes to what is the energy losses and cost, so their flywheels is taking, I think, up to 20% of per hour energy losses, but it gives the maximum life cycle. And lithium ion also, the life cycle is less, but it can give the better efficiency. But at the same time, you can see the per kilowatt hour, what is the cost. Now, what is the capacity and discharge time for energy storage system? So now you know how you are storing the energy in different methods and technologies. But at the same time, when you store it, what is the discharge time? So you see from the 10 kilowatt to 1 gigawatt of capacity, the discharge time is very high for the capacitors. Particularly, the capacitors takes more time for the capacity discharge time for energy storage system. So other methods are in between the range, where depending on the lifetime of the cycle, it varies. So when it comes to when you mix with the technology and in storage installations, how the efficiency varies from, as long as you see from 2011 to 2016. So maximum we utilize lithium ion and lead acid. These are the mostly, and by mixing the technologies, we are able to produce this kind of energy. So till now we have seen what are the kinds of different energy storage systems, and now we will see some case studies where this kind of energy storage systems, like see, the first project is that Prilia pumped storage project in India. It generates 900 megawatt instant generation. It costed around 2,953 crore. and it was commissioned in 2008, and duration is 4 to 6 hours. The benefit is that electric energy time shift and electric supply capacity. This is the real project has already commissioned in 2008. The view of the Purulia project will be something like this, where there is a upper dam and lower dam, and in between they generate this hydro pump technology to generate the power. So these are the other pumped hydro storage plants in India. In Srisalem pumped hydro storage, that is up to 1670 megawatt, and Nagarjuna Sagar it is up 700 megawatt, and Bihar pumped storage 150 megawatt, Sardar Sarovar pumped sector that is 1450 megawatt. These are the case studies which hydro storage plants are developed in India. And when it goes to thermal energy, one of the example is that which was happened at Spain. It generates 150 megawatt and expected generates up to 495 gigawatt per year. It was commissioned in 2009. This thermal energy storage system was established at Spain. And another project is electromechanical energy storage system. This is the name of the project is Beacon Power. The location is in United States, US. The plant capacity is 20 megawatt plant. And here they use 200 flywheel that provide frequency regulations services to grid operator. And it was commissioned in year 2014. And the benefit is frequency regulation. So till now I have seen the types of the energy storage systems and what are the technologies, and now and where the applications are established as a case study we have seen. Now we will see few technologies in detail. The energy storage systems. The flywheel is one of the energy storage. It is the form of momentum in a rotating wheel or cylinder. The principle is something like this. An electric motor spins the rotor to a high velocity to change the flywheel. During discharge, the motor acts as a generator, converting rotational energy into electricity. The power electronics are used to ensure that output voltage has appropriate voltage and frequency characteristics. And this is the principle. And the advantages of this flywheel is that high power density, high cycle life, and quick recharge, independent, and power and energy sizing. And what are the disadvantages means low energy density, large standby losses, potentially dangerous failure modes. So what is the theoretical formula? The energy density is defined as a energy per unit, that is E by M equal to half V square. So where V is the circular velocity of the flywheel and the strength of the material and density of the material rho. So what are the properties of some materials used for building flywheels? So they use different kinds of materials: steel, aluminum, titanium, polymer, carbon fiber. These are the materials they use for building the. And advantage is very compact when compared to other storage systems. These flywheels are used for starting and braking locomotives. A flywheel is preferred due to lightweight and high energy capacity. It is not economical as it had a limited amount of charge and discharge cycles. So coming to this is the another kind of compressed air energy storage system. So the air compressed and stored in a large underground spaces and is later used as a gas turbine generator. Smaller hybrid systems, that is less than 50 megawatt. And the advantage is huge energy and power capacity. And it has a lot of disadvantages like requires special location, expensive to build and maintain, slow start, and an unlikely candidate for distributed resources. So how it operates is that uses of peak electricity to compress air and store it in airtight underground caverns. When the air is released from the storage, it expands through a combustion turbine to create electricity. So what are the advantages is that fast startup, and the drawback is that geological structure reliance. So you need a very big geological structure to make this kind of setups. So another technology is called pumped hydroelectric energy storage. So water is pumped from low elevations to higher elevations to store energy as gravitational energy and run down through hydroelectric turbines to generate electricity. So there is a height difference between the elevations where the energy is generated because of this gravitational energy distribution. So what are the advantages is that huge energy and power capacity, and disadvantages are that requires special locations, expensive to build, not suitable for DER. So the operation is how it operates. It consists of two large reservoirs located at different elevations. During, as we have seen, the Pulupura project, there are up and down elevated reservoirs are there. During peak demand, water is released from the upper reservoir. Production exceeds demands, water is pumped and stored in upper reservoir. Pump is used as a combined motor and dynamo. The advantages are most effective with large capacity of electricity, that is more than 2000 megawatt. So geographical dependence. So it depends on the only geographically located reservoirs only we can apply this kind of setups. The capital cost is massive because of huge money has to be invested. And there is a problem with soil erosion, land intrusion, and filtering of dams. The another kind of storage method is that magnetic energy storage, called as superconductors. So superconducting magnetic energy storage systems is a storage energy in the magnetic field produced by current flowing through a superconducting coil. This energy system principle is based on inductive energy storage in the magnetic field produced by current flowing through a superconducting coil. The DC current is converted to three-phase AC output using a solid-state power conditioning system. This is the principle. And when it comes to the pros and cons, higher power and quick recharge, and low energy density, and large capacity classes and expensive. At present, what is status currently viable for short-term power? For example, 1 to 10 megawatt power range, and proposed applications in PQ and transmission support. Several demonstration projects have shown the capability of the technology in these applications. High initial cost is the major obstacle for the technology. So SME systems store energy in a magnetic field created by the flow of direct current in a coil of superconducting material that has been cryogenically cooled. The principle is that at low temperatures, electric current encounters almost no resistance, stores energy in the magnetic field, environmental friendly and highly efficient. This is the advantage of the system. And these are the specification of the system. Depending on the peak field and ratio of the coil's height and diameter, the capacity of storage varies. So another kind of technology is the supercapacitor. This is one of the storage method. Here the capacitor is nothing but a use of thin film polymers for the dielectric layer, which creates the potential between the films. Carbon nanotubes and polymers are practical supercapacitors. In future, carbon nanotubes with ceramics is a technology which can be will be evolved slowly and reduces the effect of fluctuations and longer time lifetime, which reduces maintenance and cost. So electrochemical and super ultra capacitors, also known as supercapacitors, ultra capacitors, are electrical double layer capacitors. Actually stores the energy in the electrical double layer at an electrode or electrolyte interface. So it is actually the advantages are high power density, higher cycle life, and quick recharge. And cons are low energy density, expensive, slow voltage curve requires power electronics. Energy and power density of electrical supercapacitors. The energy and power densities of electrochemical capacitors fall between those of batteries and conventional capacitors. So when it comes to the status of these capacitors, currently viable for bridging power in the hundreds of kilowatt power range, smaller power range, long-term energy storage applications of electrochemical capacitors for residential peak shaving is another application that is currently under consideration. Use of electrochemical capacitors for multi-megawatt utility applications that are require several hours of energy storage, particularly peak shaving and load leveling are the important characteristics of this technology, and it is not feasible at present. So what are the types of batteries when it comes to the electrochemical storage? The small capacities, lead acid batteries, and large scale. They use actually chemical reaction to do work on charge and produce a voltage between the output terminals. The efficiency of the cell is only 15%. So the working of lead acid battery is something like this. So when you compare the different types of battery energy storage systems, you can compare the lead acid, nickel, cadmium, and sodium sulfur, lithium ion, and other this one. So out of this, I think lithium ion having the self-discharge rate is very less, that is 1% approximately, and the power also it creates 200 to 315 in terms of power efficiency. Other can be compared. So these are the comparison between the different battery energy storage systems. So when it comes to the installation of lead acid battery across the world, these are the year of installation. I think starting from 1986 till late 90s, these many lead acid battery storage installations have happened. And you can see the rated energy, which is of very nominal power. And underground thermal energy storage using methods of heat exchange like aquafied thermal storage, usage of underground water, and duct thermal storage, usage of plastic tubes. So these are the underground thermal energy storage systems. So it has environmental impact also. The applications of thermal energy storage is that air conditioning. A salt hydrate acts as a cool heat sink for the air conditioner working fluid, and this is a method for the application of thermal energy. The stored heat is directed from the salt hydrate during night to heat the surrounding air. And the example is the sodium sulfate decahydrate. So this is the method of regenerative fuel cell storage system. A fuel cell is an electrochemical cell that converts a source fuel from combustible substance such as hydrogen, methane, propane, and methanol into electric current. This is the fuel cell definition. So a fuel cell is a device that generates electricity by a chemical reaction. Every fuel cell has two electrodes, one positive and one negative, called respectively anode and cathode. The reactions that produce electricity takes place at the electrodes. Hydrogen is the basic fuel, but fuel cells also require oxygen. One great appeal for fuel cell is that they generate electricity with very little pollution. Much of the hydrogen and oxygen used in generating electricity ultimately combines to form a harmless byproduct, namely water. So this is the way the power is generated using fuel cell. So as I told, it's a direct conversion between energy into electricity by burning fuel. It's a high efficiency, and the applications for the fuel cells are NASA and viable alternate petroleum engines. And what are the types of fuel cells? It is classified based on the operating conditions and various electrolytes used. Alkaline fuel cells, polymer electrolyte membrane, phosphoric acid fuel cells, molten carbon fuel cells, solid oxide fuel cells, regenerator fuel cells, as we have seen before, earlier slide. And what are the energy densities of some energy storage methods? When it comes to hydrogen, the energy density is something like 38 kilowatt hour per kg, and gasoline 14 kilowatt per kg, and lead acid batteries 0.04 kilowatt hour per kg, and flywheel hydro storage is around 0.3, and flywheel is 0.05, and flywheel earlier was steel, it was carbon fiber, and fused silica and compressed air. So the highest density is generated using hydrogen energy storage method, which is you are seeing in the at these figures. So what are the advantages? So no greenhouse gases, not much political dependence, more operating time. And disadvantages are storage of hydrogen due to high inflammable nature of H2. So metal hydrates and NH3 can be alternative. High capital cost due to platinum catalyst used in the process. So out of these energy storage systems, now the question comes, which is the better? So by comparing one method to another method as an energy storage system is pointless, because the reason was that only one thing. None of them are optimal for all purposes, because depending on the application, depending on the need, the technology and method and the energy storage system needs to be identified and to be utilized. So different storage methods and different in capacity and maximum usable storage time. These are the specifications where we need to choose according to the requirement. For large scale storage, underground thermal, pumped hydro, and compressed air energy storage systems are preferable. But as we discussed, the name itself, it says the large scale storage. So we have a huge plant establishment needs to be made for this kind of systems, and large scale storage we can use underground thermal and pumped hydro and compressed air methodologies. Superconductors can store energy with negligible losses. So as you can see, superconductors in a sense like a capacitors. So even with this technology, we are using in our smart applications also this kind of superconductors to store the energy like batteries. And fuel cells are viable alternative to petrol engines due to their high efficiency. And flywheels have a narrow range and are not an answer for large scale operations. As I discussed, for large scale operations, and we go for the underground thermal as well as pumped hydro, compressed air methodology. So when it comes to you have seen different types of energy storage systems. Why you need this kind of what is energy and why you need to store the energy, and what are different types of energy storage, and what are the advantages and disadvantages. All these things we have seen. Now coming to what is the future of energy storage system, we should know now. So the energy storage evolution electrifies the future of renewables. So the more energy you can store when you use the renewable energy sources. So at the same time, the changing regulatory outlook also is important, and enthusiasm grows as a prices decline. So when it comes to the energy, it is cheaper prices. The development will go faster for this kind of applications. And what leads the next frontier of energy storage is another important question. So what types of storage do you foresee being instrumental in the grid of the future? So when it comes to the energy storage, so the highest right now is in the instrumental in the as a grid utilization. Electrochemical battery, we are using 63.4%. Particularly, you can give as example as our smart gadgets and electrical vehicles, automobile sector. So many, we can say, electrochemical battery based. And the second largest is pumped hydro, where you can store a lot of energy, but because of huge initial investment cost is there. But for larger storage requirements, this is one of the best method to store energy. The next comes to the thermal energy, that is 19.30%. Thermal also one of the large storage energy method. In the fourth place, you can say compressed air is the method where we have 14.9%, and followed by hydrogen 13.7%, and flywheel is 9.9%, synthetic natural gas 5.6%, liquid air 5%, and rest of the natural renewable energies are somewhere around 19.9%. So for the sustainable development, so these are the things we need to see, particularly good health and well-being, affordable and clean energy, decent work and economic growth, industry innovation and infrastructure, life on land, climate action, responsible consumption and production, sustainable citizen communities, and life below water, peace, justice, and strong institutions. These are the sustainable development goals. We have to use energy as per the standards. In a nutshell, that when you come to the conclusion, the reliable and affordable energy storage is a prerequisite for using renewable energy. Energy storage, therefore, has a pivotal role in the future. So energy storage is the most promising technology currently available to meet the ever-increasing demand of energy. So these are the things we can conclude. The energy storage is very much important for the day-to-day human life cycle, and the technology needs to be developed in a faster way to reach the demand by supplying the energy with the various advanced technologies. That is the conclusion of the energy storage system and innovations. Thank you.
Thank you, sir. Dear participants, if you have any queries, any questions, you can ask the speaker.